Hi, it's Dave. Welcome. Today I'm joined by Yannic Kilcher. He runs an artificial intelligence and machine learning YouTube channel. It's a popular YouTube channel followed by many people in the machine learning and artificial intelligence community. I've got a lot to talk to and ask Yannic about regarding Tesla's autonomous driving approach, machine learning, the future of AI, what's going on. I want to get a better glimpse of the progress being made in artificial intelligence. So Yannic, I want to welcome you on the show. How are you doing?
I'm doing excellent. Thanks for having me.
All right. Yeah, I've been watching a bunch of your episodes during the past year, and you do a fantastic job breaking down what's going on with artificial intelligence and machine learning. I'm curious, just kind of to start off, what are your just first impressions, initial kind of ideas, thoughts regarding Tesla's autonomous driving approach? Does anything stick out for you when you kind of, think about and look at their approach?
It does stick out that it is a direction that the entire field is moving into, which is we want to learn more from data itself and less from sort of human engineered things. There are things that can be programmed, and that's great, but there are things that are too complicated to be programmed. And then you have a choice, like, how much do you want the machine to do by itself? And Tesla does go into the direction of having the machine do a lot of the stuff by itself. And then essentially the programmer just has to make sort of the high level decisions, program in, if this situation arises, do that, and so on. But the whole task of perceiving the world and sort of building an internal model of what the world is on the outside, that's left to the machine learning algorithm. And I think that's pretty cool. I mean, as I said, it's not unique to Tesla, but it's pretty cool that they're pushing on this front, especially in a crucial area like driving, which is like has some more security issues than, let's say, classifying images of fruit or so.
Yeah. I'm wondering what's your take. I've noticed, let's say 5 years ago or so, a lot of people were skeptical that vision or cameras alone could be able to do a driving task sufficiently, and therefore they thought they needed more sensors like Lidar, et cetera. And some people still think that way, but it seems like the progress that Tesla and others are making with just vision and being able to construct a vector space and see all the objects, their velocity, the positions, and all this stuff was something 5 years ago people weren't expecting this fast. That all this progress could be made. What's your take on vision? Has it been moving faster than you expected? And are there limits to this? Like, are there going to be? Is it a place where do you think just cameras and neural nets can sufficiently perceive, the physical world in a way where it can be possibly safe to drive even much, much better than humans?
I think it's important to remember sort of the fundamentals, and I think that's what Andrej Karpathy has pointed out at some point as well, is that you as a driver have essentially two cameras. You also have a bit of your ears, so that might be important. We might need some sound recording, but essentially you as a driver are able to solve the driving problem with just your eyes. And sort of that is the fundamentals that we work with. So, irrespective of the engineering problem, it must be possible to drive a car given just cameras. And I think that's what the approach is going for. Now, that is not to be said that there can't be an approach where LiDAR or something like this helps. Obviously, if you have some depth sensing, you can recognize stuff that's ahead of you. But then there's also a problem. There's noise in these sensors as well. You have to integrate the signal. Like, what if your two systems disagree? What if your camera system and your LiDAR system disagree? And I believe that was already the talk before the kind of recent interview with Elon Musk, where they talked about, they consistently found that their vision systems were more accurate than these other sensors. So they just kind of dropped a lot of these other sensors. So I think, from fundamentals, that's important to remember. How far along we are until you really can relax back and let the car drive, I have no estimation on when that's going to be, but I'm very excited to see like the demos. People kind of like cautiously letting go of the steering wheel and letting the car drive. It is impressive, and it's gonna
Yeah.
make mistakes. Yeah.
Yeah. I've noticed in some of your past videos, you've mentioned, how driving it's very high stakes. It's like could be life and death, and therefore it's it's an area where it could possibly take a little bit longer, than people expect, because it has to be at a certain level that's very, very safe, and that's definitely, I think, one of the challenges unique to autonomous driving, because it's yeah, just barely passing is not going to be good enough, especially with yeah
Not even human level, right?
yeah
Because
exactly
if it's just at like the level of the average human, it's still going to be, everywhere in the news whenever. Imagine every time a human made an accident, it's in the news, right? Like
yeah
your news would be full of accidents because they happen every day. So this thing needs to be 10 or 100 times better than a human.
yeah and
Yeah.
yeah, and also this thing of machines or neural nets, computers will make different types of mistakes than humans, that humans just won't be able to understand or tolerate or accept. It'll just seem so stupid to a human, some of the
Yes.
mistakes that these neural nets make. And that's going to be, at least initially, a very difficult thing for people to accept, that you have these computer-driven cars that are possibly even killing people with stupid mistakes in their view, even though statistically they might be safer by accidents and death. It's still going to be, I think, probably an adjustment process. How do you view that situation?
Yeah, exactly. We know that there are, even though neural networks are sort of modeled after the human brain-ish, like it has diverged in the recent years quite a bit. We know that people and neural networks or artificial neural networks, they make, yeah, as you say, different types of mistakes. Mistakes where you'd go like, oh, why? This is so dumb. So yes, exactly what you're saying is true, but we can't let the car companies hide behind that, right? Every time they do an accident, they can't just say, well, it's different, right? It's important, as you say, we look at the statistics, we see, look, this is 100 times less error rate than the average human, and we should base our evaluations on that. And it's, I guess, as same as with the pharma companies, it's also important where the statistics come from. So, if it's the car company's own statistic, maybe trust it a little bit less, right? Or if they funded the study, than if it's sort of an independent research institute. So all the usual caveats apply. I think, as long as people retain their common sense,
Sure,
it's going to be fine.
yeah. I mean, I think with cars, you have the advantage where there is more objective data. For example, the number of miles driven, number of accidents, number of deaths, number of major injuries that can be reported, versus pharma. For example, the side effects might be a little bit harder to track exactly, what's going
Sure.
on. So
Yeah.
maybe a little bit of a tighter feedback, with data. Yeah, you mentioned about integration issues. So let's say companies, like, it seems like there's a bifurcation, like a divergence, where you have some companies saying that they can solve autonomous driving with just cameras and neural nets, artificial neural nets, and others who think that they need more sensors like Lidar and radar and others. And you mentioned there could be some challenges with integrating multiple sensors. How serious of a challenge is this? And also, with those relying on Lidar, I mean, correct me if I'm wrong, but it's my understanding that they'll need to have really good vision as well to not just read signs, but to figure out what type of objects are there as well. Like, to actually find the texture and the actual, identifying things to make the environment safer. So if they're needing vision, but they're relying on Lidar, then do they just need to integrate that? And do you think that is something that will be doable, will be achievable, and is something you're kind of optimistic about? Or do you think there's going to be some kind of bigger challenges for that in the future?
Yeah, there are multiple issues, right? First one you named is sort of the basic one, street signs and something like this. These are made for humans. As we said before, you solve the driving problem just with cameras, and therefore the environment is as far as we can make it, is made for you. The road, the lane markings are visual, the street signs are visual. However, just from a fundamental perspective, more data is probably better, unless it's like super noisy, right? More data is probably better. A LiDAR, even if you just use it in the case where it says, stop, there's something on the road that you can't see yet because it's dark or foggy or something, right? Just kind of on the brakes, there's something there. That's going to be useful. Now the question becomes a trade-off, like how useful is it? And as I said, integrating these things, it's a current research direction in our field. Usually that's referred to as multimodality, like more than one type of signal. People right now are researching images and text, or video and text, or images and sound, things like this, that our neural networks can handle these different types of data better. But this is still, I would say, in earlier days than sort of the computer vision domain.
Mm-hmm. With LiDAR, would you see, like, one of the pros and cons is you'll get so much data initially, and you could, initially do generally like impressive driving very fast off of that data. But in order to, I guess, compensate or solve the weaknesses of LiDAR, to understand the world better, and adding on multi modals like vision and et cetera, that I guess compared to a vision only approach where you're not relying on this physical sensor of LiDAR, what would you see would be the pros and cons of each approach? LiDAR versus vision only.
Yeah, I mean, as I said, with LiDAR, there's more data. Like you're going to be able to see stuff that the cameras don't see, right? That's just a given, because you have one more sensor. There's going to be more input, so technically it's possible to see more stuff. In practice, that might not be. In practice, the overall addition might be a net negative, because there's more noise. We don't understand LiDAR data as well as we do vision data, all this kinds of stuff. So I have no clear winner here, right?
Yeah.
I'm excited to see what these companies can do with these sensors and how they're going to solve it.
Yeah, definitely. Regarding, I guess, the physical world, Elon Musk has been saying recently that, by trying to solve full self-driving, they by necessity have had to go more into the physical world. And I guess he's referring to the whole idea of perceiving, using neural nets and the data through cameras to perceive and understand the world, and the objects and how to interact with those objects. Do you think Tesla is in the lead in terms of physical world kind of AI? If not, who do you think are kind of the leaders in that field?
That's a hard question. I'm probably not qualified to say who is sort of in the physical world. I mean, it can be robotics or so. There are a number of robotics companies that are quite leading. For example, I don't know, Boston Dynamics comes to mind. However, there is also a question, how much AI is there really in each of these robots? A lot of them are very heavily pre-programmed or things like this. So, I mean, it's a bit of a question of what you want to do. But yes, I think Tesla and many of the car companies have discovered that the self-driving problem is essentially a very hard problem if you really want to solve it fully, because not only do you need to recognize everything around you, but it goes as far as you have to understand like society, because how you interact with other drivers is sort of a societal convention, right? It's like, I cut in front of you, I kind of know that you're going to brake, because otherwise our insurances would be, not happy with us. And so yeah, it's probably a more difficult problem. I couldn't tell you who's like ahead in physical AI.
Got it. Thinking, okay, so I'll toss a hypothetical situation. Let's say AI advances, super quick as it is, and let's say a company or companies like Tesla progress with autonomous driving and they go into AI robots. Do you think that a company like Tesla can go into other types of AI fields based upon their growing expertise with navigating the real world? Can they go into things like, language and just other fields of AI that kind of overlap with some of the current more, digital world leaders like, DeepMind or OpenAI, et cetera? What are your thoughts on that?
Definitely. I mean, this is a trend in the last, I would say, years. In the last few years of AI research, has seen a bit of like a convergence of models. It used to matter much more what kind of data you work with, and now we have a much more unified neural network architectures, such that it doesn't really matter what type the data is as long, like, it's a different problem from multimodality. It still matters whether you have one type or two type or three type, but for a given type of data, be that images, text, speech, music, genetic data, whatever, we are much more seeing all over, like, the same architectures over and over and over again. And therefore, yes, definitely the companies that are doing autonomous driving could easily transfer over into some other field. Conversely, companies that are now doing large language models or whatnot could conceivably carry over into autonomous driving, at least the AI part of that in the future.
Sure. How about data? I mean, do you think could be harder for, let's say, the digital companies to converse over to the physical world, in the sense that they would need access to the data that perhaps physical objects, could provide? If they can solve that problem, the data problem, then obviously they could port over all their AI expertise. Like, how important is that data, to kind of mastering, the physical world with AI?
Very. Like, it is, I mean, in the last 10, 20 years, everything has become free, right? Almost every software you use has become free. And that is because the software has become less valuable, and the more valuable things are the data that's collected using the software. So if you use Google, if you use any of the social networks, they will collect data on you, among other things, to sell you things, right? But also because that's really what powers their competitive advantage. So yeah, I do agree that, like, data collection, data warehousing, and so on, that is currently, it is a big part of the competitive advantage that these companies have against each other.
Mm-hmm. Like, how much, I'm curious, like, let's take an example like autonomous driving. How much data do you really need, let's say, to really solve this problem? For example, does it matter, let's say, if a company like Tesla has, let's say, 5 million cars, let's say in 3 or 4 years on the road, collecting data and all these edge cases, et cetera, versus, let's say, a newer company that has 100,000 cars on the road collecting data in the same way? Does Tesla have, like, I'm just curious, like, in your opinion, with, the importance of data, is it a huge lead, or is it something that actually another company with a smaller data set can use other approaches and somehow compensate for that lack of data and still, solve the problem? What are your thoughts?
We know that there is an intrinsic trade-off between the amount of data and the quality of data. So you can get away with much less data if your data is of substantially higher quality. There are also, every day, there are new techniques that make use of kind of smaller data sets that say, well, we can train the same thing, but we only need 10% of the data or something like this. Now, how much that exactly means in the real world is yet to be seen. But if a new competitor wants to compete with a company that's already super established, they will have to find a way to increase the quality of their data, given that they don't have the quantity. But if they manage to do it, at least from the current standpoint of machine learning, they do have a reasonable shot.
Interesting. Do you think in the future, do you think the long-term competitive advantage of AI companies will be their AI expertise, or do you think it'll be more their data advantage?
Well, that is a good question. The expertise is, well, let's say these people move between companies, right? Like the top research departments of the top companies, they see people moving in between them all the time. So it's not like they sit on secret, there's some alchemy involved in machine learning currently, but it's not like there's a vault and there's the recipe in there or something like this. The data is a competitive advantage, definitely. Compute is a competitive advantage, especially against like smaller competitors. So I'm more thinking like if, I don't know, Google against some smaller search engine, just the raw compute power they have is enough to kind of demolish other competitors. But also there, we come up with newer and newer technologies where people need less compute.
Mm-hmm. Yeah. I'm curious, what are your thoughts on Tesla's Dojo project? It seems like a super ambitious project, for a so-called car company to actually think about making a neural net chip. Do you think there's a pathway for success where Tesla can actually, I guess, push the envelope and make one of the best, I guess, most cost-efficient, type of chips, or just, I guess, compute, right? They're trying to, in effect, I guess, trying to bring down their cost of compute so they can train larger and larger neural nets. Do you think they can be successful? What are the challenges that you're seeing with Project Dojo?
It makes total sense. Our current hardware is multi-purpose. Even like we have CPUs, which are super duper multi-purpose. You can do almost anything on them. We have GPUs, which you can use for gaming and training neural networks, right? But they're still very versatile. And a company like Tesla might not need that. They might not need that versatility because they say, we want to train this one neural network, as big as possible, as fast as possible. Then it makes total sense to make a chip that's very specialized in that. Note that it won't be like a general AI computer. It will be very specialized to the specs that they need to have, that they expect, in the near future, in the midterm future, we're going to do these types of things. So, yeah, I think lots of the big companies, they come up with their own architectures for what they expect. And it makes a lot of sense because it saves them so much money in the long run. So I'm not surprised they're doing that.
Mm-hmm. Yeah. It seems like such an ambitious project because obviously it's not just the chip itself, it's all of the tooling and software and platform around that they need to build, that NVIDIA has already built for many, many years, and they have a huge developer ecosystem supporting that. It seems like a daunting task, but it also seems like perhaps there is this belief in Tesla that they might really need this, that it could be worth it because their ambitions are so big. Do you think going out, like if Elon thinks hypothetically, which obviously it's up for debate, that Tesla is getting close to, solving, let's say, a level 4 FSD, but why would Tesla need such like big compute ambitions for the future? If they're thinking next few years they're going to be able to solve level 4 FSD, like what's the purpose of planning so far in the future with, let's say, Dojo, or saying that you were going to need, I don't know, orders of magnitude greater compute power, for what we want to do? Where is that coming from, do you think?
I mean, these are just fundamental scaling laws of our industry. If you want to get better by a certain amount, it's gonna take more and more, exponentially more compute. So that going up orders of magnitude isn't something necessarily special in our industry. That is kind of, if you don't change anything fundamental, you can get better, but you have to go way bigger. And if it's on their radar that they need to be not only on par with humans, but 10 or 100 times better, then if it's one of the things they'll have to do almost.
Mm-hmm. Yeah. So you've mentioned a few times, like, okay, we have a few parts of AI that seem to be crucial. So you have the whole data, part needing not just quantity, but also quality data. Another part you've mentioned is compute, just having the immense amount of compute that it takes to train these large neural nets. Are you seeing, like, I'm not like by any means like an expert in this field, but it seems like these neural nets are getting bigger and bigger, and it seems like the result is the performance is getting bigger and bigger, or better over with that. Is there any limit right now, you think, to where this is leading? And do neural nets just continue to grow bigger and increase in performance, or do you think there comes a point where the approach starts to change a bit? Where it's not just the size, but also, I'm sure there's other parts of the neural nets that are changing as well. But what's your take on how neural nets improve going forward?
It is really special at the moment because it used to be the case that people thought up new architectures and new smart ideas to make the neural networks better, and it turns out we can just make them bigger. And that is, I think that there hasn't been anyone that hasn't been at least a bit surprised by that. Even the people that claim, oh yeah, of course, like this is surprising. For the largest models that we have currently, we do not see an end currently to this scaling law. The only real limitation is what I said before, that in order to make the next step of improvement, we always need like an order of magnitude more data, more compute, and more time. More data, more compute, and more model size, right? Mm-hmm. So we need to scale these three things in accordance with each other. But if we do that, we do get better. And there's not yet been a stop to this. So, there are projections about when AI training is going to surpass like the power consumption of New York City or so, but we're not there yet. I can't tell, when it stops.
Yeah. I mean, that's interesting. Like, it seems like, AI is just in this trajectory. I mean, what you're saying is like, if you have the data that, let's say, is scalable, you have the compute power. Let's say you have unlimited compute power, unlimited data, and then you're able to grow these neural nets, the models. It just seems like, it's just, I don't know, possibilities seem pretty crazy.
At some point you're going to hit. Well, you're going to hit one of those limits. Like there isn't going to be more silicon around to build more chips, or you've exhausted the entire internet of for data, or at some point there's going to be like a practical limit to this. The interesting question is whether or not there's a theoretical limit, but that's another a different issue.
Yeah. So is there any way like people are quantifying how quickly the field of AI machine learning is moving forward? Like, for example, I had a viewer leave a comment on one of my videos saying he doesn't think AI is progressing fast because he's a software developer and he's not using AI and he's not seeing AI in his company much. And I'm like, I don't think you're in touch. So for those people who, and that's the thing, it's like you could be a software developer and not really be exposed or understand exactly how fast this industry is moving, because maybe your field, you're just not, using it much. But for those who don't have an idea of how fast is this moving, like, is there any kind of quantifiable ways? Like, is the kind of neural nets becoming, let's say, doubly, effective, or the performance doubling every year or every 2 years, every 6 months? Or is there any way that we could, for example, with Moore's law with transistors, the double, transistors double every, let's say, 2 years or so. Is there anything with AI that we could kind of track similarly?
There surely is, and I've seen a lot of those projections, but they do disagree quite a bit. So there is, for example, there's one website called paperswithcode.com, and that shows sort of the progress over the years on standard benchmark tasks. And that can be like a way to measure, but remember that is on standard benchmarks. Standard benchmarks don't do much for the real world person that, has to live their life. I don't subscribe to necessarily like the singularity hypothesis that AI is going to overtake everything and so on. I think there will be some technologies coming out that will make our lives a lot easier, right? But I more think what I said before, that at some point there's going to be like a limit, a practical limit to these improvements. That being said, your friend, the software engineer, I don't know how long ago it is, but now with the release of like GitHub Copilot, it's a game changer for software engineering. Like I'm using it. It is really like it is a game changer, and that's just sort of that. I think products like this will make a big impact.
Yeah.
Without saying that AI is going to overtake everything.
Interesting. Yeah, I mean, so Copilot, how's your experience been with that? So I know like there's been like OpenAI has had Codex, and then you had DeepMind with the AlphaCode, but it seems like people aren't, correct me if I'm wrong, but you can't really try out DeepMind's like AlphaCode project, right? Even though Codex, there seems to be, they're doing demos. I've seen a video, but with at least GitHub, you can try this out. You could use it. Like, is it what you're expecting in terms of, the help that you're getting with coding?
I mean, it needs, AlphaCode, I don't think it just came out like last week or so. And I'm not sure how or whether DeepMind plans on publishing any of that. Codex is just the model behind Copilot, right? So the Codex you can actually try out if you have OpenAI API access. You can try out Codex just in a text field, and then it's what powers Copilot. And Copilot it needs some fiddling. Like I think it needs some like UX, considerations and things like this. But it is totally like the entire task of writing what programmers call boilerplate code is like cut in like to 10% or so.
Oh, wow.
It is insane. You like write a function, you give the function a name. If you name the parameters, reasonably, it'll just do it for you. And all you do is need to check whether it kind of does the right thing.
What code have you used it with, or what language? Sorry.
I've used it mainly with Python and I believe with JavaScript. I don't actually remember if it does JavaScript, but those are the languages I'm using currently, and it's really good. Yeah.
Oh wow.
It's not always correct, but it's like often enough.
Yeah. How quickly do you think this is going to like revolutionize coding? Like, do you think this is going to take, just within 2 or 3 years, we're going to see this really take off, or do you think it's going to take a bit longer than that?
Well, it depends on what you mean by take off. It can take off right now if I think it is really useful as like an autocomplete thing, because our IDEs, they used to autocomplete like variable names or function names that we would, I don't know how many of your viewers are programmers, but you usually, you write a piece of code, let's say in a function, because you use it over and over again, and then you call that function. It has some name. The name might be 20 characters long or so. And instead of typing the name every time, our text editors are kind of smart, and they suggest the name to you when you start typing the name. A bit like, Gmail auto-completes your email for you. What Codex does is this, but bigger. Like it will suggest multiple lines of code to you at a batch, and all you do is quickly check whether it's correct and then say yes. And this is, like, as I said, for boilerplate code, it's insane. Yeah.
Yeah. Interesting. Okay. So let's take a step back for a second, and look at the bigger picture. For those who, let's say, aren't technical and don't follow AI that much, what would you say is like to them if they ask, why is AI important? What's the big deal of artificial intelligence? Like, is it really going to change much? Like, where is this headed? Why are you so interested in it? Is there anything any light you could shed on that angle or that topic?
Yeah, AI has in recent years has really made a lot of progress on what might be called perception problems, which computers weren't really amenable to before. Computers were good at things you could program, calculations, running Excel and things like this. They weren't really good at recognizing what's in an image or in a video, or understanding a piece of text that a human has written. That is not like a sequence of commands to a computer. And this is changing rapidly. So you might have realized that in the last years you were able to start searching photo libraries, like image libraries, using text by just describing what's in a picture and not necessarily the tags or anything like this. I think in Google Photos you can do that. You type in mountain, it'll bring largely pictures of mountains and things like this. You'll be able to auto transcribe and translate meetings in real time because the AI can understand both speech as well as language and translate between them. You might have noticed Google Translate and similar things have become insanely better. It used to be a joke, right? Google Translate used to be like, oh, I use Google Translate. Yeah. Now you go to Google Translate, it's like, yeah, that's fine, right? It's not entirely perfect, but it's as good as someone who's kind of proficient in the other language. So these things are already here. On top of that, things like, think of TikTok or so. The entire thing that serves you content on a platform like YouTube, like TikTok, like Amazon, that's powered by an AI system that is in real time figuring out what you like and what you don't like. Now, you can think of good use cases for that, or you can think of bad use cases, but it's like it does touch lives more than people think.
Mm-hmm. Yeah. Do you how do you see this playing out? Like, do you think that it's going to augment people's productivity and jobs where, they just get more productive, or do you think it's actually going to replace jobs and lead to kind of a loss of jobs? Like, are you optimistic, I guess, in terms of artificial intelligence and, impact on people's jobs, or a bit more cautious?
Personally, I'm very optimistic. I'm not I'm not very well versed in economy or anything like this, but it would be like the first time that a technology would really replace jobs. And sure, you might argue AI has that potential, but I more see it as an enhancer. And I'm not going to say you will be more productive, but you'll have the opportunity to be more productive. You'll also probably have the opportunity to waste more time, but you'll at least have the opportunity to be a lot more productive with AI assistance.
Sure. I'm curious, who do you think is in the lead in terms of, I'm sure there's obviously more niche approaches, niche projects that a ton of companies are doing, they're the leader in that field. But however, in the bigger kind of the big fields, like for example, with what OpenAI or DeepMind is doing, or maybe even Facebook AI, I don't know. Who do you think is kind of pushing the envelope the most with kind of big AI projects?
It entirely depends on the area you're looking at. So I think OpenAI, for example, has gone the most route of let's just make stuff big, but have focused on text, on images and things like this. Largely, there's a bit of reinforcement learning. DeepMind very much pushes this direction of life sciences or things that are related to that. A little bit reinforcement learning. I don't know if you've seen AlphaCode and various things like this, but they have a big. Their mission is to develop really this AI, this intelligence, and sort of accelerate science as such. That's why they go into protein folding. Facebook Facebook is doing a lot of research, more in the visual domain, also in the text domain. Google maybe a bit more in the structured information domain, but also in tech. So there's overlaps. It's really hard to say like who's in the lead or whatnot. What we do see is amazing things appearing almost like on a weekly basis from any of these places, and then some more, right?
Yeah.
So yeah, I don't think these companies would probably claim that they're competing with each other, but it's not that much of a competition. There's still so much to like do.
Yeah, I see. NVIDIA, are you optimistic, bullish on their future? Do you think they will kind of keep pushing the envelope with hardware and just provide kind of this core, hardware to the AI field? Or do you think, I don't know, what's your take on NVIDIA? Just curious.
Yeah, it's a hard problem. I don't know. I really don't know that. It could be that sort of they are at their last hooray and just milking kind of this sort of monopoly profits they have, or it could be that they just use this momentum and just continue to dominate for 20 more years. I have no idea. I just know like Facebook just bought thousands and thousands off of their most expensive GPUs just over the last year to build their supercluster. So they don't seem to be in trouble right now. Like that's one thing to be said.
Sure. So with OpenAI, with GPT-3, they've kind of created a lot of buzz over the past couple of years with that model and what it could do. Do you have any expectations on what, let's say, a GPT-4 could do in terms of like how much improved it could be? Yeah, what's your, and do you have they released any idea of when they might release the GPT-4?
There has been, I believe there was one talk where I'm not even sure who, but one of the sort of more senior people in OpenAI have hinted at what GPT-4 may look like. And what they've hinted at was that they don't necessarily make it much bigger, but they do change some fundamentals in the architecture. And it leads back to what we said before. In order to kind of gain the improvement, they would need to make it 10-ish times bigger or so, which it does. Like, it already probably hurt them a lot to train GPT-3, just money-wise. Training a model that's 10 times larger is a hard and expensive thing to do. In terms of what it might be able to do, I think there are still a lot of weaknesses in GPT-3, that you could easily point out. It is impressive, but there are still a lot of weaknesses, and probably a lot of them will be alleviated, let's say, and there will still be weaknesses, but there will be a lot less.
Interesting. Yeah, it's going to be interesting. So much is happening, it feels like, with artificial intelligence compared to just even like 5 years ago. 5 years ago feels like a long
definitely.
time ago. So with Tesla Bot, what do you think are the main challenges in creating an AI humanoid robot that can successfully navigate and interact with the world and with people around? And how is that going to be different than what Tesla's doing with their full self-driving cars? Like, do you think they're going to be able to use, most of that expertise to build on, or I guess, how challenging do you think this humanoid, robot project is going to be?
Yeah, that is obviously a question that people in our field are discussing. The general consensus is that it is a much harder problem. You're right. Probably, if they manage to do a good job on the self-driving side, probably a lot of that can be transferred over in case they want to build a bot like this. But just the practical considerations of something that walks on 2 feet is already, like, that alone is already hard. And then it needs to be in an environment that it doesn't know. That is extremely hard, right? A car is still on the road, and roads sort of are similar, but like the real world, that is that is insane, right? It's really at the far end of the spectrum, where on one end you have the robot arm in the factory that does exactly, it can be reprogrammed, but it does exactly one thing with like super precision. This is on the other end of the spectrum. I would be cautious promising this anywhere in the near future in a working version. That being said, it might work in like a limited setting, like where it's kind of a known environment and the things that it needs to do are known beforehand, or at least the types of things it needs to do. It might work there, but the general like idea of a humanoid robot probably still quite a couple of years away.
Got it. Yeah. So, I mean, what I'm hearing you, or I don't want to put words in your mouth, but it feels like you're saying like, it needs to be like, it's going to take a while before this thing is in everyone's house, doing chores and washing dishes.
Yeah, it depends for what, right?
Yeah,
it depends.
yeah.
It depends entirely for what. But if it's a limited use case, then you might also ask, why don't you build like something on wheels? It's much easier, right? If it's just in your house, like or like Spot by Boston Dynamics, it seems like such a better model to navigate the real world than like the difficulty of being on two legs alone is insane, right?
Yeah. 4 legs. I mean, that's like a lot easier, I guess. Yeah. I guess one idea is they could, Tesla can deploy it first, I guess, in their factories in some type of controlled environments, doing some repetitive tasks, and try to, I mean, it seems like to get it into people's homes, it just the magnitude of different situations, are just so vast. And the types of tasks that people will require to do are just so mind-boggling. It just seems like early versions. I wonder if it's even going to be like net useful. You know what I'm saying? Like considering how clumsy and how many mistakes it could make, or it just there's a certain point where it's like, is it really worth it to be there? But then again, like with exponential improvements year over year, at some point it could be, probably a super useful, tool inside the house. It just seems like it's not going to happen as you're saying in the next, couple of years.
I mean, I've been just my own personal opinion is that this is like such a hard problem that if they deploy it, they will have to scale down what it can do to the point where it's kind of, people might feel a bit like, yeah, you promised something different. That being said, I have been surprised enough times to not like rule out the possibility that, this is going to be a good, like a nice addition to a household or something.
Yeah, definitely. Yannic, it's been super fun chatting with all this stuff about AI and autonomous driving, robots, the field. Super fascinating stuff. I'll go ahead and link to your YouTube channel. I believe your YouTube channel is Yannic Kilcher.
Yes.
Covering machine learning, artificial intelligence, to cover the latest news and papers out there. You have some great interviews as well. I'll link to your Twitter account as well. Is there any places you could recommend if people are interested in artificial intelligence and machine learning to keep up to date with what's happening? Any good Twitter accounts? Any good websites or any places like that?
It depends a little bit on, let's say, your level of interest. I personally am mostly in the research space. If you watch a few of my videos and follow the links there, you'll discover the kind of the things to follow. Or I mean, you don't even have to watch the videos. I guess you can just click on the links in the descriptions. For general AI news, I wouldn't necessarily know myself. I mean, there are pop science like Wired or so. They have enough stories about things that are happening. You probably won't miss the big stuff if you generally just read tech news.
Interesting. Okay. And then on a personal note, like before the conversation, you're noting you're in Switzerland. What do you do as your day job?
I have a startup together with 3 of my co-PhD students. We do natural language processing, mainly in the legal text space. So legal tech for lawyers, for anyone who has to do with contracts and laws and regulations, stuff like that.
Awesome. Yeah, sounds great. Yeah, fascinating, good stuff. Appreciate taking the time out to share your insights. Thanks, Yannic.
Absolutely. Thank you very much.
All right. Cool. Awesome. Thank you.